Welcome back. At this point, we made it. Our game is finished and everything is in there. We have animations, we have sounds, we have particles, we have our gameplay, we have our game loop. Everything is done. But we haven't touched the C++ side of things yet. And it'll become apparent why we haven't done this, right? You'll quickly notice once I start messing around with this that it takes time. It's slow. It takes a lot of closing and reopening the editor, so it's not ideal for efficient learning and quick learning, and for the amount of time that we only have available to do this course. So keep that in mind. All right. So I'm going to open up my Epic Games Launcher real quick. And if you go to the Unreal Engine then Learn tab, you'll see the Programmer Quick Start. If you click on that, it will open the website with a very nice tutorial that kind of, you know, um, explains how you can create a cube. So you can spawn a mesh and then manipulate the cube all through code. So I would strongly suggest that after watching this video or doing this follow along, either to the video or the documentation that I've written, to kind of give this one a go as well. There's a big overlap, of course, with what we're going to do now, but it'll give you some additional things to come in contact with, like spawning and manipulating objects. All right, but we're not going to touch this in our little tutorial here. What we will do instead is we are actually going to take our health component and create a C++ variant of it. Right, so we will recreate our health component that we made and fully set it up in C++. It's not going to replace the health component. It's just going to be, going through the steps and showing you how we could convert this. All right. Additionally, as well, in the documentation, you'll see that there's this link, right, that will take you to the programming introduction page. So I'm going to quickly open that one as well. So bookmark this page because this is kind of a landing page where you can then go ahead and access all the different bits and pieces of information that you might need to do the C++ programming. It'll go over how you set up and initialize your properties, the hot reloading that you will see in a moment, how you can extend your C++ blueprints, and so forth, right? So don't forget about this website. We'll go over it as well real quick, but always fall back to the documentation. Should things change or should you not know something, always go there. Good. So let's get started. The first thing that we'll do is go back into our project and we'll add a new C++ class. So I'm going to click on add new C++ class, and in our case we're going to create an actor component. So I'm going to recreate our health component. I'm going to go next, and I'm going to call this health component, like so. I'm doing this in a copy of our original project because something went horribly wrong, as things happen to do with C++ side of things. It can happen, so I'm redoing this video real quick. Hopefully not run into the same issue that I had before. Um, the final thing that I want to mention here is that you have some options here as well, depending on your project structure. You also have public and private. Look at, if you want to know what this is for, there's also some documentation about that. It's basically, you can have a bunch of different ways to structure your C++ project. And depending on your needs, or if you're making a plugin or whatever, you might want to use different setups here. But in our case, and in most cases, just having the default header file and source file setup will be more than sufficient. So stick to that. Right, let's create a class. This is going to take a while, so I'm going to edit the video here. I'm going to fade out and then fade back in once everything has been compiled. And then I'll also quickly go over um, some potential problems that you might run into and how you can fix them. All right, so my code has finished compiling and my project has been updated. And as you can see, um, in my C++ classes, under my Unreal Introduction, you can see the health component, which is excellent. This is what I want, right? My new code is here. Now, should you run into a situation where you get this error, right? Successfully added class health component. However, you must recompile the Unreal 101 main. This is going to be the name of your project, so it won't probably be Unreal 101 main. So should you get this error, there are a couple of things that you can do. the first thing should be close down Unreal and open it up again. See if that fixed your problem. If it didn't, next thing that you can do is again close it down. And if you head over to where your project is located, there are a couple of files that you can always delete. You can always delete your .vs folder. You can always delete your derived data cache folder, intermediate folder, and saved folder, as well as your solution folder. All those folders and files can be auto-regenerated. Um, in, in case of your solution file, you can always right-click on your uproject folder, executable I mean, and if you have installed everything correctly, you can actually generate a new Visual Studio project here. All right, so keep that in mind. That can probably help your problem. Then what you can also do is open up your Visual Studio and try to build your project first, and then open up the actual editor. Right? So should you run into that problem, those are the steps that you can take to kind of fix it. Should you still run into problems, then it's going to be something deeper, and then you'll have to take a deep dive in the log and see what exactly is happening. All right. So once everything has been compiled, my Visual Studio also opened, and you can see that we have our health component.cpp, our health component.h, so our header file. And if we look over here on the side, we can also see that our health component can be found here. Good. Now, another advantage of creating our code files through the editor is that it actually gives us some start code, right? Because it knows that we are creating a component, it already generates the component structure for us, which is ideal. We see that we already have some metadata here, right? We have some pre-made functions. So we have our tick component, our begin play, basically the things that we would have if we were to create a new blueprint component. So this will help us quick start the whole thing. Now, let's head back to the editor real quick and go to our blueprints folder and then select our destructible actor. And we'll use our destructible actor just as a test bed to see if our code is working and if all the elements are in place. All right. So let's see, we have our event graph here, and I'll add a component, and I will add our health component. So that's our new one. So it's the health component, not the BPC health, but the health. And let's add it. There we go. So we're going to use that later. For now, let's just hit compile, let's hit save, and let's head back to our Visual Studio. Good. I'm first going to go a little bit over the structure that we're having here. So at the top, you will see that we have included our core minimal. That's actually the engine, minimal version of the engine. We also included our components, actor components, because we are going to use the component system. And then we also have a health component.generated.h. This is an automated header file that includes a bunch of additional information. You can't access this. This is happening behind the scenes because remember, C++ in Unreal is not just standard C++, it's actually kind of a managed C++. There's stuff like garbage collection and all of that stuff in place. So it's not a pure C++, right? That's also why we have all these macros here that we'll get into in a moment. Something important to note as well is that classes in Unreal always will start with a U for Unreal class, right? So a U health component, U actor component, and so forth. And we have our typical things like I just mentioned. If we head over to our health component, we also see that we have our initialization at the top here. Here we can set our default values for our variables. And then we have our begin play and tick components that already call our base implementations using super. Good. Now, as we want to recreate our health components, I'm actually going to open up the health component. And let's have a quick look. So we're going to have a bunch of variables, right? We're going to have max health, current health, and invincibility time on damage. We didn't use that one. That's something that you can do yourself. We're going to leave that one out. We're going to need an event dispatcher. we'll have functions, right? Pure functions. And we have a regular function reset health here as well. Regarding the interface, I'm gonna touch this in a moment when we start adding the do damage function. But yeah, interfaces will not the same interface will not be usable in our C++ file, but I'll touch on that once we get there. All right, so let's get started. Back into our code file, I am going to copy paste some things. So just to speed things up, I'm going to add a public variable. And I am just copy pasting this from the documentation that I provided with these videos. So we can do the same as well. And we have our protected value member variable for current health. So our max health and our current health. And if you look at our max health, we actually have some additional information above that. We actually have a U property definition. And what that will do is this will basically tell us that the editor can display this value. I could perfectly leave this out and have a public value, but then this will only be available through code. No one in the editor will be able to see this value, access this value, or edit this value. But we don't want that. Our max health, we want to be able to configure our max health within the editor. Now, if I go to the documentation real quick, and this link is also in the document that is provided over here. So if I have a look at that website, you will see all the different property specifiers that you can use within Unreal to set up your properties, right? So we have metadata specifiers, we have um, property specifiers, property tags. So if we have a look, let's put this next to each other. We have uProperty edit anywhere. So what does the edit anywhere do? Well, we can have a look on this website, and this will say it indicates that this property can be edited by property windows on archetypes and instances. The specifier is incompatible with any other of the visible specifiers. Right? So it means, well, you can edit it. Then we have blueprint read write. Let's have a look at that one. And it basically says, well, this property can be read and written to from a blueprint. So specifiers is incompatible with any blueprint read-only specifier. So they are exclusive of each other, mutually exclusive of each other. So we need this information to say to the engine, hey, this needs to be accessible through blueprints. And just as we had before, we can also specify a category. In our case, we're going to specify the health category. Now with our properties defined and our variables defined, we're going to head over to the CPP file and we're going to initialize our values. So my max health, I want this to have a default value of 100. Like so, and I'm going to initialize my m underscore current health. I'm going to initialize that to max health, like so. Okay, let's save everything. And as you may or may not have already seen, my IntelliSense is not really acting that well with me. That's because Unreal is a big engine and there's a lot of code files in here, so it takes a while to process everything. So during this video, you'll probably see the occasional hiccup. Hopefully we won't get into too much problems here, but just know that your IntelliSense will not always be correct or indicate the up-to-date information, right? And provide you with the up-to-date information, I mean. So let's hit the build startup project. You could also use compile single file, but in my case, that doesn't always work. Building the startup project usually does work, so then it will make, it will compile everything that hasn't been compiled yet. So I'm gonna let it run. And in the meantime, I'm also gonna head over back to our Unreal project and open up the destructible actor. Like so. And once the compilation has been done, we're going to check if we actually have our value in here. So let's open up for compiling. So this might take a while, so I'm going to skip ahead in the video and return once the compile is done. Okay, so my compile has completed. I can see that everything was successful. And if I now go back into the editor and have a look at my health component that we just added, I can see my maximum health, right? So the value is available. Luckily, the hot compile was able to do everything that we needed, so we don't have any issues. All right, cool. Next up, I'm going to, let me open up the health component again. I'm going to add our reset health event. So going back into our code, I'm gonna go to the header file, and let's declare our function. So again, I'm going to copy paste it for the sake of time, and then go over it. So I'm going to add a reset health function, and above that, again, we have a macro, we have a U function. And in the same vein as we had our property specifiers, if I head to the website and go to the U functions and head over to the U functions specifier, there we go. We can also go and see what all the different options are that we can use, right? The meta tag modifiers that we can use and so forth. So whenever you want to use something new or you come across something that you don't know how it is affecting your function or your property, always come back to this web page and this should help you forward. Right? It also shows you how you can declare everything and so forth. So in our case, we have a blueprint callable. So this means that it will be callable from a blueprint. And our category is health. Okay, same as the other ones, is going to add it to the health. Now, if we head over to our CPP file, we can just add our function at the bottom, like so. So we're going to set our current health to our maximum health. Good. Make sure that everything is saved. And let's build and compile again. And while we're waiting, I'm going to go over to the U function documentation. And let's have a look at blueprint callable. This function can be executed in a blueprint or a level blueprint graph. Perfect. All right, so that went fairly smoothly. And now let's see if it actually worked. And this is where things might go wrong and often will go wrong. Whenever you add new functions or make big changes to your CPP files and to your header files, well, in those situations, you might end up with the Unreal Editor not able to hot reload everything. So you can see here at the moment, if I hover over my health, it's using a hot reloaded health component. So it's not using the fully compiled health component. It's kind of like a temporary in-between version that has the up-to-date code, but it's going to be a variable type hot reloaded. So be careful with that, because if you then start doing things and if you then close down and open up again, things might break as well. So let's see if we can call our reset health. See, and as you can see, reset health is not available. That's because our hot reload hasn't really succeeded. I'm probably going to be able to search for it though if I go to all possible actions and then search for reset health. You can see there is a reset health here. The target is the health component and I can add it, but I won't be able to connect it. See, hot reloaded health components, zero object reference is not compatible with health component object reference. So keep that in mind, and this is something that will happen often. So in those cases, the best thing that you can do is close down Unreal and open it up again, and then everything should be fine, because again, the code has compiled correctly, as you can see here at the bottom. So make a good habit out of whenever you're compiling your code, basically just close down the editor. It's going to be safer to begin with, and you'll always end up with the correct results. Otherwise, certain things, especially when you're testing and adding it to blueprints and so forth, things might go horribly wrong and break and give you serious headaches. So if you want to be safe, just close down the editor, then hit compile. So I'm going to quickly restart my editor and then I'll get back to you. So after a restart, I can now get my health and then call reset health without any real problems. All right. So let's head back to our code. Let's go to the header file, and I'm going to quickly also show you what we're going to be doing next. So let me minimize this real quick. Open up the health component. And just for our own sanity, I'm going to do a couple of things in succession before we come back to the editor. Again, because most likely I'll have to close it down and open it up again. And I want to minimize the amount of times that I have to do that. So what we're going to do next is we're going to have a look at how we can create our pure functions, right? If you remember, pure function is just that you don't have an execution pin that comes in. You can just get the values, kind of like property getters. So we're going to create our two pure functions. And then after that, I'll also start looking into having our on do damage function. In our original implementation, we used an interface. We won't be using an interface though, but we'll just implement that do damage function because our do damage also has return value, as you can see here, right? So that's also going to be an interesting thing to set up. We can have, if we select this function, actually, if we were to look at the definition, we can have multiple return values if you want to. So if we were to look at our interface definition here, we could have 20 return values potentially, right? So how are we going to deal with that? I'm also going to show you that. And then after that, we'll head into the event dispatchers. All right. But I might come back to the editor first before I do the event dispatchers. All right. Okay. So let's head back to the code. So the first thing that I'll do is I will add those pure functions. Just gonna copy paste these two. And the biggest difference to have a pure function is basically that we are defining a const function. So as soon as we define a const function in on the C++ side of things, then Unreal will recognize it as a pure function and expose it like that in the blueprints, as long as we have blueprint callable defined. So these are pretty easy to add. So let's head over to our CPP file and just add the two functions here. It's nothing too special about them, right? We did it before in blueprints. So we get our health percentage, our return value is a float, and then we get our is dead, and our return is a bool. And we just check if those things are true. All right, cool. I will test them in a moment once we have added our different elements. Now, I also want to add our do damage. If you recall correctly, we did use an interface to define or do damage and our setup in our BPC health component. However, our interface that we defined was created in a blueprint. It's a blueprint interface. Unfortunately for us, we cannot use that interface on the C++ side of things. Now, if you were to have created a C++ interface, the story would be different because our C++ would be aware of that code, right? But in our case, the C++ side of things cannot be aware of the blueprint side of things, unfortunately. At least not at the moment when making this tutorial. It could be that this changes over time or in the future. That would be really cool, but as far as I know, at the moment it isn't supported. Or at least I haven't been able to find how it was supported yet, if it was supported yet. So instead we'll just add a function and we'll set it up in the same way as our interface, right? It's going to have the same definition and the same setup, and it's also going to have the same input and output variables. So that's the most important thing. So let me copy paste this declaration here And let's have a look what's different. So first off, we do have our blueprint callable, right? So we can call it from blueprints, but then we have some other things here. We have a blueprint native event. I'll get back to that in a second. And then we don't have a bool return value. Nope, we actually have a bool reference property value here. So why is that? Well, we could just return the bool and be done with it, and then we have a function that will return one value. But if we set it up as a by reference parameter, then we will actually end up with a situation where we can have multiple return values, right? We can have as many as we want, and in the blueprints side of things, it will recognize that and add them as our return values. So using this setup uh, is going to be a lot more flexible. Now, the blueprint native event, I'm actually going to open up the documentation for that. If we have a look here, we have our blueprint native event, and basically what this says is this function is designed to be overwritten by a blueprint, but it also has a default native implementation, which is interesting, and declares an additional function named the same as the main function, but with underscore implementation added to the end, which is where code should be written. The auto-generated code will call the underscore implementation method if no blueprint override is found. So what exactly does that mean? Well, it means that our auto-generated.h will add a variant of our function that has the underscore implementation added to it. But I'll explain that, I'll show that in a second. Important to note here is that we also have two other options. We have our blueprint implementable event, this one, and this is basically saying that the function can be implemented in a blueprint or level blueprint. The C++ side of things will have no implementation whatsoever. So this is only to provide something like a hook, right? If you say, um, you know, I did damage, and then the blueprint can then take that event and add whatever code that is needed. On the base side, on the C++ side of things, nothing is provided there. It's just a hook to add additional codes through blueprints. All right, so that's important to know. And then we also have a, let's see, well, if we take away the blueprint callable, right, then if you just have blueprint callable, then it means that the function is um, fully defined in C++ and you cannot override it. So you cannot override the blueprint callable within a blueprint. So these are the three that are really, of key importance here. All right. And again, there's also in the documentation, there's another overview of that with some information on how that is set up. Good. So if we look at that again, here we have our do damage, and this is a blueprint native event, meaning that we will have an implementation here in our C++, and we will be able to extend it in blueprints if we inherit from our health component. So let's copy paste that code real quick. And again, if we remember how we set up our BPC health, if we look at our do damage, right, we stored our original health, we changed our health value, we clamped our health value, and then we checked, well, are we dead? And if so, call the onDead event. So we're going to do exactly the same. We cache our current health, we subtract our damage amount, we then clamp our value. Um, Here we're going to add something in a moment, right? We're going to call a damage event here. And then we have our is dead check. And if we are dead and we actually changed our health value, well, then we're going to call the onDead event, which we are going to add in a second as well. Okay, good. Now, you will also see all the red squiggly lines. Even though if I were to start a project now and compile, I will most likely have a succeeding build. This can often be the case, when adding new code. The IntelliSense won't be able to recognize it at first glance. especially if we have a look at the health component.h our header file. We have do damage here, but we have no knowledge of our do damage implementation. And even if we compile the code, it could be that if I open and close this, that it still won't be recognized, right? In such a situation, the best thing you can do is close down your Visual Studio and reopen it, and that should most likely resolve itself, because then it will have reloaded your auto-generated.h file. Right. So I'm going to quickly close this down and go back to the editor to just have a look at our setup and to see if everything is working. So I'll also restart the editor because it's most likely that our hot reload will not have worked with this because we added a new function. So I'm going to stop the video here and come back to you when I have reloaded both my project and my Visual Studio. Okay, so after reloading, I'm back in the editor and let's have a look. I'm going to go to my BP destructible actor. I'm going to head over to my begin play and let's do some testing of all the code that we have just added. So first off, I'm going to get my health percentage. Let's see if that is working. All right. I'm also going to see if I can get my is dead. So is dead. Okay, that's also working. And then of course, let's check if our do damage is also working. So let's go and do damage. Do damage. There we go. Our do damage is also there. And as you can see, we can do our damage amount and we have our is dead. So if I say I'm going to do damage of 100, let's see if this works. So I'm going to connect this. And after that, let's see how we can hook this up. So if that is true, so I'm going to add a branch. So if we died like so, I'm going to print a string and say, well, I died. Like so. Okay, that's going to happen on the event begin play. I'm not going to call these two because they are actually used in our do damage. So we'll know if these are working. Let's hit compile, let's hit save. And we have 3 of them here. I'm going to remove 2 of them, 2 of my destructible actors. And let's hit play. Oh, I died. There we go. If I check my log as well, you can see my damageable actors said died. So that code seems to be working. Good. So moving forward, we are going to add our event dispatchers. So we have our onDead that we call here. We're going to add this one. But we're also going to add another one. We're going to add an additional event that's going to be fired each time we do damage. And our event is actually also going to give return value. It's going to say, well, we have X amount of damage. So it's going to be an event dispatcher with return values, because that's a little bit different to set up. So let's go back to our code. And for this, we are going to add a multicast delegate, a dynamic multicast delegate. So first gonna add the onDead. And I'm just gonna add it here. And I'll quickly go over this in a second. And I'm also gonna prepare the next one, or on damage one. I'm gonna also put it beneath it like so. And let me open up some documentation about this as well. So here's the multicast delegate documentation. We also have, if we look at the side here, we have dynamic delegates. And I want to draw attention to the top here, this Unreal Engine 4.9 documentation. So this has, this thing hasn't been updated in a while, and you can see that there's some HTML, like, it's not really displaying the documentation correctly. But just know that you can find the needed information here. In this case, is declare a dynamic delegate. That means that you can have one connection, and we can also have multicast delegates, which means you can have multiple connections. Now, what do I mean with connections? It's like events in C#. Basically, other classes, blueprints, or whatever can um, be added to the multicast delegate. It's kind of like a subscription system. You subscribe to it, and then whenever an event happens, the multicast will broadcast the event and say, well, something happened, and everybody who is listening will receive an impulse and know that, okay, the event has happened, and then can process whatever they want, right? So that's the importance of those multicast delegates. Now, here you can find how you can declare them. It's a bit tricky to read because of the errors here, but I'll show you in our little example how we can set it up. And then we also have a link here to a legacy wiki document that also shows you how you can set it up, the signature, with multiple outputs, right? For example, 6 parameters and so forth. And we're going to create those as well. So I'm going to show you how to do it. So first off, we are going to create our signature. We're going to declare a signature. So in this case, I'm going to declare an if on that signature, and that's going to be a declare dynamic multicast delegate. It doesn't have any additional parameters or anything. It's just an event like we have in our blueprint component. All right. And then using that signature, I'm going to declare this over here. I'm going to declare my event, right? My broadcast event. Good, my dispatcher. Above that, you can see that it's blueprint assignable, which means that I can assign in blueprints. And again, this is something that you can find in that documentation page that I showed you earlier. Just know that this one is needed for multicast delegates, and I put it in the same category. Now below that, I have created another signature, an on-damage signature, but this time it is a one param signature. And how this is structured is, again, I have the name of my signature, and then I say, well, this is my my type that I want to pass along. If I hover on this, you can also see it. I have my parameter type, and then I have my parameter name. All right. If you want to know up until how many of these parameter delegates are defined, you can have a look in in your source code. You can actually search for it and see the declaration. I think it's up to 10. And I think you can also add more if you want to, but it's going to be rare that you need so many parameters, because then you would just, return a container or a struct that contains all your information, right? You're not going to have that many different return values, preferably. So these are our two multicast delegates. All right, let's have a look. Let's implement them. And this is actually really easy. So once they are declared, you can just add a on damage in this case, and it's going to be on damage.broadcast, right? It's going to broadcast this event to everyone who is listening, and it's going to pass along the amount, because that's our one param multicast delegate. And in this case, it's just going to be a simple on broadcast. We don't have any additional parameters that we want to give along, and that's going to broadcast to everything and everyone who is listening. All right, going to save this up again, compile it, and cut the video real quick, because I will also need to reload my editor, because this is a big change, right? Whenever you add functions and do stuff like that, then you need to close down the editor and open it up again for the changes to be taken into effect without any real problems. So my code has compiled, and I have restarted the editor. I'm gonna go back to my BP destructible actor, and let's see if everything is in place here. So I'm going to select my health, and indeed I have my on dead and my on damage events. I'm going to subscribe to both. So I'm going to add my on dead and my on damage. Let's move them to the top here, and let's have a look. So indeed, this is a simple event without any values or parameters, and this one has our damage amount just as we specified it. And let's also hook them up, so let's see if they are working. In this case, we're gonna print. We're gonna set this to blue. I'm gonna say on that has been registered. Just as an example. And on the bottom one, we're going to say the following. So I'm also going to add a print string. And I'm actually going to do something here. I'm going to create a append, string append. So I'm going to construct a string here, add a pin. Actually, you can also remove a pin. So if you right click, you can remove a pin. And I'm going to take my damage amount and drag it to the second parameter, and you can see that it can auto-convert. That's because they provided that support to convert a integer or a float to a string. And we're going to say, ouch, that hurts, and add our damage amount after it. And let's put that color to red or orange. All right, let's hit compile. Let's hit save. Let's hit play. And there we have it. So if I now look at my output log here real quick, ouch, that hurts, 100 damage, and then on that has been registered and we died. So our events are working, they are being sent from the C++ side of things, and we are receiving them correctly. Awesome. Now, I also want to check if my my blueprint native event is working correctly. So I have my blueprint native event. I want to make sure that that is also working correctly. So let's have a quick look. And we're going to come across something specific here as well. So I'm going to create a new class, and I want to inherit from my health component. But as you can see, it isn't available here. And that's a good thing, right? By default, your C++ classes will not be available for inheritance in the editor. It's kind of a safety mechanism, right? As a programmer, you want to be in control of who can, you know, extend your code, basically. So in order to make this, to get this to work, we need to add something to our uClass definition. So we're going to add a meta property, or a meta tag more specifically, and we're going to add comma. I'm going to add blueprint base. Is blueprint base equals true? So what this will do, this will basically tell the compiler that, hey, this class, it can be used as a blueprint base and you can inherit from it. Okay, so once this has been defined, then we can go ahead. So again, I'm gonna hit compile, and I'll be back in a second. Once again, we're back. So if I now right click and create a blueprint class, I can now search for health, and you can see that now my health component is available. I'm going to select that one. I'm going to call it BPC health child. And let's open that one up. And now we're going to do some verification. So I'm going to click on the icon here, show my inherited variables. Let's open this up, open this up, open it all up. And I can see, indeed, I have my events here. If I click on them, nothing will happen because I can't inherit from them, right? I can't overwrite them, which is good. That's how we set it up. And then let's have a look at the variables. My max health is here, so that is also fine because we made it available. And then if I look at my functions, I have two overridable functions. So let's look at the overrides, and indeed my do damage is overridable. I can create an override for this. So if I click on this now, you will see that it will automatically generate the override function. I can still call the parent implementation, remember, the underscore implementation version, and then also have my own implementation or completely fully overridden function of that function call. So I also reloaded my Visual Studio project, and you can see I have my squigglies here, but it's no longer red squigglies. So I feel a lot safer now, right? Everything is nice and clean, and everything seems to be working. Okay, so that's very quick and very rough. Uh, an overview of how we can use C++. Well, not per se rough, but just a quick overview of how we can use C++ and how we can use the most important, macros in here. So just keep in mind, if you want to have these properties, you need the U property. You need to look at the documentation of what the available options are here. But in most cases, they will always use the same ones, right? Or variations of the same ones. Same thing for your U functions. That's how you control how your U functions will be available in blueprints. And then if you want to create these events that you can subscribe to and that you can use to set up communication between different components and different elements, then you need to use the dynamic multicast delegates, and that's how you define them and how you set them up. Okay. Now, again, if I go back to the documentation page, I would also have a look at this tutorial here. Combined with what we have just seen, you should get a pretty good start to get going with C++ and Unreal. Especially if you then think about, well, we have made our entire project here and we have basically touched all these different elements of the engine. Well, the C++ equivalence of that should be fairly easy to set up because the naming conventions and the workflow is going to be exactly the same, but this time it's going to be in code, right? So if you know how you can do something in Blueprints, you can always go and search in your solution here because you can access your source code, right? So for example, if I were to, let's see if I can actually search for this one. Let's search for the dynamic multicast delegate one param. So I'm going to let it search. Just know that you can actually search in your source project, and that's an important thing, right? Having the option to look at how Epic Games has set things up in their own components and their own actors, then you can take that and extend from that and learn from that. So if we have a look here, you can kind of scroll over, then you can see, well, they are using it in a bunch of places. And after some searching, you will probably be able to find the actual declaration of that and see if there are other variants as well. Let's have a look here. So these are the definitions from all those components that you can see and that you can use in the editor, right? So that's an advantage that you have, and use it. It's impossible to know how everything is set up because this is a big engine. So use the tools available, and that should get you where you need to be. Again, as a reminder, final reminder, should you ever get errors and warnings and so forth, always look above your warning as well, because that will hint you what was actually happening before you got your error. Especially in Unreal, I haven't really come across situations where I can say, well, this error is exactly telling me what is happening. It's always the thing that's happening in front of it that informed me and pointed me in the correct direction of where I should be looking. All right. And with that, I will leave it here and end our video tutorial series. Thank you for watching.